Hi there, my name is Miss Townsend and I love math. Welcome to Math with Townsend. This video is for academic students working towards the June EQAO, and it's video number 2 of the solutions to your practice package. And we start here with question 7. It says Deacon has a candy making business. The graph below shows the total number of candies his business has produced by the end of each day for the first 4 days. If this trend continues, which of the following points represents a day with more candies produced than expected? Well, I want you to really focus here on some vocabulary. The word trend and the word expected. When we have a scatter plot and we talk about the trend or the expectation, we're talking about what the points tend to look like. And primarily in grade 9, we're looking for a linear trend. And that linear trend can be represented by a line of best fit. So to find the trend of a scatter plot, you draw a line of best fit. So let me get my fancy tools here, and there's a line of best fit. And again, a line of best fit doesn't necessarily go through all the points, although it looks like this one did. A line of best fit merely fits the trend or the pattern of the scatter plot. So ideally, you have the same number of points above the line as you have below the line. Now in this case, I have 0 above and 0 below, so that seems to work. And so what we're looking for in the question is which of the following points represents a day with more candies than produced? More candies produced than expected. So above the line here is where we're making more candies than we expect, and here is where we're making less candies than we expect. So let's see what happens. So the point 500 is right here, and that's perfectly fitting with the trend. 850. So if on day 9 you did 850, again, that seems to be really darn close to that trend line. What about 1300? Oh, well, 1300 is right about here, and I would say, let me just clean this bit off here that we don't necessarily need. I would say that 1300 definitely seems to be quite a bit above the trend. Let's check the final point before we make any conclusions. 1400 is right here. So definitely the third point is above the trend line, and in this case, above the trend line means more candies than expected. So the answer would be C. It's the only point that doesn't fit the trend. Question 8. Karina has a job at a video store. The total she is paid each week is made up of an hourly rate plus $14 for transportation. 1 week she works 20 hours and is paid $215. Which equation represents the relationship between Karina's total pay in dollars and the number of hours she works? So we know that every week she gets $14. That is not an hourly wage. That is a flat rate. So no matter what, if she works 0 hours, apparently she gets $14 for transportation. If she works 10 hours, she would get $14 per transportation. If she works 80 hours, she would get $14 for transportation. In other words, $14 should appear in your equation just as $14. So if you look at equation A, I see plus 14. That makes sense. But in B, 14n doesn't make sense because 14n would suggest that she gets paid $14 for every hour she works, and we know that that's not the case. So it can't be B. It could be C because I see plus 14. That makes sense. But in D, again, I don't have plus 14. I have 14n. And again, that would represent being paid $14 every hour, and that's not what we have. So now I have a choice between A or C. So let's think again. So we know that 1 week, Karina got paid $215. So that was made up of a certain amount of money for working 20 hours plus $14 flat rate. So in order to figure out what this amount of money is, I'm going to subtract $14. That gives me $201. Oops, $201. So $201 for 20 hours of work represents what rate of pay? 201 divided by 20 gives you $10. $10.05. So Karina makes $10.05 an hour plus a $14 rate for the transportation, and therefore the answer is C. Which value shows a linear relationship between C and N? So we look at first differences. So for N, I'm always going to have this plus 1, plus 1, plus 1. So in A, I have plus 2, and plus 4. Nope, that's not linear because this is not a constant rate of change. Here, plus 1, plus 1, plus 1, plus 1, plus 3, plus 5. Oh, that's definitely not linear because that is not a constant first difference. So it's not B. Plus 1, plus 1, plus 1, plus 4, plus 7, plus 4. That's weird, and it's definitely not linear. So hopefully we see linear in D. Plus 1, plus 1, plus 1, plus 3, plus 3, plus 3. Good. Hopefully that's a question that we can all get perfect marks on because it's fairly easy to look at a table of values and do the subtraction you need. Question 10. Which relation does not have an initial value of 50? So think about this question in terms of a graph. This question says, if you were to graph these 4 lines, one of them does not start right here. So 3 of them have a starting value of 50, and one of them doesn't. And don't forget, the starting value is also known as the y-intercept. And a y-intercept is where x equals 0. So one way to find it, if you don't already know, is to let x equal 0 and see what happens to your y value. In A, there is no x. So if I let x equal 0, I got y equals 50. In fact, you should know that that's a horizontal line at y equals 50, and that definitely has an initial value of 50 because it has only values of 50. Part B, if I let x equal 0, 8 times 0 is 0, this is definitely a starting value of 50. C, if I let x equal 0, I get y equals 0. This is not a starting value of 50. So my answer is C, but we'll double check by looking at D. If I let x equal 0, this is a starting value of 50. So therefore I'm right. The answer is C. The graph below shows the relationship between Rena's distance from home and time. During which section of the graph does Rena travel the fastest? So because it's multiple choice, you don't just want to go right into doing all kinds of math. We always look for ways of getting to an answer faster. So for example, P and Q are both traveling away from home. And I can tell just by looking that the steeper line is P. And again, steeper lines means faster travel. So steeper means faster. So between P and Q, I know P is faster than Q, so I'm going to cross off Q. It can't possibly be Q. Between R and W are both traveling home. Clearly R is faster than W, so I know it's not W. So I'm down to looking at either P or R as the fastest lines. And again, if you're still not sure by looking at them which one's faster, we can actually calculate slope. So here, P is 1.5 over 2. So the slope of P is 1.5 over 2, or 0.75 kilometers per minute. The slope of R, let's see, I go from here to here and then over. So this went from 4 to 2, so this is 2 over 2. So the slope of R is 2 over 2, which is 1 kilometer per minute, which is faster than 0.75 kilometers per minute. So the answers are or C. So again, the steeper the slope, the faster that line segment represents. So here's a table representing a linear relationship. Find the equation. So first of all, it's not y and x, so it's not y equals mx plus b, because I'm not using y and x. I'm using d and t. Secondly, you can see right here that you have your y-intercept. So I know that the y-intercept is plus 5. By the way, you'll notice I haven't even looked here yet. I don't even know what the answers are. I'm going to try to do my work on scrap paper and then see if my answer is there. So I know the starting value is 5, and then the slope, so delta x is plus 1, delta y is plus 10. So my slope would be 10 over 1. So the equation is y equals 10t plus 5. And there it is right there. And to be honest with you, even if I ignored anything to do with slope, as soon as I saw that the starting value was 5, I could have been able to say nope, nope, and nope. So hopefully that's a nice and easy question for you to do if it showed up on this year's EQAO. Question 13, simplify fully. So again, here we're thinking about polynomials, collecting like terms, multiplying monomials, all that great stuff that you love. So let's do the math together as a family and see what happens. So we have to follow the rules of Bedmas. Let's talk through it. Bracket. Well, inside this bracket, is there any math I can do? No. 4 is a constant term, meaning no variable. 3x has an x. Therefore, these are not like terms. So I can't do 4 minus 3x. There's nothing to do inside that bracket. The next step is look for exponents. Well, there's only one exponent over here, and I can't do anything to this exponent because I don't know what x is. So therefore, I can't do exponent. So the next step is to look for multiply, and you should recognize that there's multiplication right here. So between negative 5x and that bracket is multiply. So this term says negative 5x, and that has to get multiplied into the bracket. So negative 5x is going to get multiplied with 4, and it's going to get multiplied with the second term, which is negative 3x. Now, it doesn't get multiplied with plus 2x squared because the negative 5x is only belonging to what's in the bracket, and this is not in the bracket. So let's do the multiply. So negative 5x times 4, I'll do that math in a second, and then negative 5x times negative 3x. So I'm showing you an in-between step, just in case this is something you haven't reviewed in a long time. So what I did was I took this binomial and I broke it apart like this. Okay, now I can multiply each piece and make sure I don't forget anything. So negative 5x times 4, well, negative 5 times 4 is negative 20, and there's that x. Now I have negative 5x times negative 3x. Negative times a negative is plus. 5 times 3 is 15. X times x is x squared. Plus 2x squared, I still haven't done anything with it yet, so it's still plus 2x squared. Collecting like terms. So negative 20x, there is no other term with just x, so it's still negative 20x. But 15x squared plus 2x squared, I can collect those. 15 plus 2 is 17, so I have 17x squared. Now, as a final little reminder, you should have learned that when you are organizing or finishing a polynomial, that you're supposed to write the terms in order of degree with the highest degree first. So this term has degree 1 because that's the sum of the exponents. This term is degree 2. Therefore, it's a higher degree term, so I'm supposed to write it first, and then the other term, negative 20x. And once I've written it in the proper order, I can clearly see that the answer is D. So that's this video done, and I will see you in video number 3.